Welcome to the PMI Capillary Flow Porometer demo. The first part is for a screw top sample chamber. We're going to do a membrane test. This is the base of the screw top chamber, and here's an adapter plate that goes inside. This is a millipore support screen that keeps the sample from being damaged in high pressure testing. This is the sample, a membrane. It's a very thin sheet which could be damaged if it didn't have a support screen. This is the O-ring to make sure you get a good seal. It seals down against the sample and then also is able to push out against the sides of that adapter plate. These tongs allow you to insert the sample adapter plate without damaging anything. Pins in the sample chamber keep everything aligned when you put the screw top on. This is the top adapter plate that goes over the O-ring, pushes it down against the sample and out against the sidewalls of the adapter. This is the spacer that goes on top of the assembly. It pushes everything down, and as you put the screw top down, that pushes that against the adapter plates. This is the screw top. Tightening this down, make sure all the O-rings get pushed together and against the sample so that the compressed air only goes through the sample and not through the sides or any leaks. This is the wetting liquid Gallic. It has a much lower surface tension than water, which means that you can test smaller pore sizes at lower pressures. This is the hose that gets attached to the top. This next part is about setting up a membrane test in the software. This is the program called CapWin. It's used to do all capillary flow testing. This program has lots of options and features, of which we'll go over a few. We can start with group selection. This is how you separate out your data files, parameters, save locations. In the top left of the software, there's a button called Group. You click that, and that opens the group selection menu. The group menu allows you to keep parameter files, data file save locations, and other information separate for different projects, users, and samples. This menu also allows you to select different modes, which change the complexity and available options for users depending on their experience with the software and their ability to use advanced settings. The second option down here is New Group. That allows you to name and create a new group. New groups should be named for the operator or sample type so that everything can be kept separate and organized. Now that we have our new group name, we can go back to the main CapWin screen. When a new group is created, it's essentially a copy of the group that was loaded before its creation, and so all the data file save locations, parameters, and other information should be the same as whatever the previous group was. Now that we have our new group created, we're going to load an auto test and make a brand new auto test from scratch. This is the advanced auto test screen with all the options open for editing. We're going to start with setting a data file name right at the top. We're going to click the line called Output File Name to select our data file and name it. Select a valid save location for the data file and type a data file name that adequately describes the test in a way that you'll remember when you go back to load it later. The next line down is the end user. That's the company or person that the testing is being done for. The next line, the test reference, allows you to find out what kind of test was run later when you're looking at the data file. Next, we're going to do the sample ID. This can be a nickname of the sample, or it can be a detailed description of the sample using punctuation that you can't use in the output file name. The next line is the lot number. It's a way to organize sample IDs and sample groups by the time that they were produced, so that you can keep the group together that was produced together. The next line is the operator. That's how you can identify who ran the test. Now we're going to select a wetting liquid. You can either load one that's been pre-saved in the software, or make a new one as long as you know the surface tension for it. Now we'll get to one of the most important parts of the program, selecting the test type. This is the test selection screen. Here we have capillary flow porometry selected, which would be pore size testing, with wet up calc dry and a linear dry curve. That means the sample would be wetted by the operator before the test, and then the sample would be pressurized, and a dry curve would be calculated by the software. Capillary flow porometers offer a wide variety of testing options. They also double as a permeameter, able to do gas permeametry, which would be permeability testing on samples, getting flow rates on dry or wet samples, and then plotting them against pressure. The standard machine can also do pressure hold, burst, hide your head, and Fraser and Gurley permeability options as well. For permeability and gas flow testing, the size of the sample is important for the permeability calculation, so you'd want to enter diameter and height of the sample. In some cases, cylinder length and density would also be necessary. Now we'll click the Edit Parameter File button. This is the Test Parameter screen. Advanced users can change these fields to modify almost any part of the auto test procedure. An easier method to modify the parameters would be to use the scroll bars at the bottom of the screen, which allow you to set the delay times at each data point, number of data points taken per test, and the speed of the bubble point test as well. On the right-hand side of the screen, parameter files can be restored to defaults, old files can be loaded, and new ones can be saved as new names. Once you've had time to double-check everything in the auto test screen, you can click Start Test to begin the auto test. Once the Start Test button is clicked, the machine will automatically reset all the hardware and begin the bubble point test. A bubble point test has a constant flow rate outputted onto the sample. That slowly increases the pressure in the sample chamber, and the wetted sample doesn't allow any air to pass through until diffusion begins, and then eventually the largest pore in the sample will open up, and the bubble point will be called by the software based on the F/PT, which stands for flow divided by pressure times time. Bubble point tests are usually set to run very slowly because you want to pressurize the sample slow enough to make sure that the machine can recognize the point at which air begins to pass through the largest pore in the sample. In a manual test, the bubble point would be determined by looking at a film of liquid on top of the sample and watching bubbles pass through the largest pore. In our machine, you can instead watch the F/PT curve, which shows that the pressurization of the sample begins to slow as air starts to escape through the largest pore. As air begins to leak through the sample, it pressurizes slower and the machine calls the bubble point. The bubble point will display on the bottom of the auto test screen, and now the machine starts opening the motor valve and increasing the pressure, which will start to flow more gas through the sample and begin the wet curve. The y-axis on the left is the flow that's being detected during the test. The x-axis on the bottom is the PSI, and below that you can see the equivalent measurements and micron sizes. The graph being displayed on the screen is tracking the flow, which is changing rapidly as liquid is being pushed out of the sample. The sample being tested here is a track etch membrane, so all the pores have approximately the same diameter, which means that the machine will detect a steep increase in flow. As it starts to increase the pressure, pressure can be correlated with pore diameter in microns, as seen at the bottom of the auto test screen. When the slope of the line on the graph starts to level off, it means that no new pore sizes have been detected and permeability has been reached. At the end of the test, the machine zeroes everything and populates the red line, which is the dry curve, which is just an estimated dry curve based on the software's calculation, being that they chose to run a wet-up calculated dry test. This part of the demonstration will focus on running a test in a clamp apparatus, which is another way to run samples, usually large flat sheets that you don't want to have to cut up and put in the sample chamber. This adapter plate has a bunch of small holes in it to support samples that are too fragile to have one large hole underneath them. This is another millipore screen for a little added support. It has much smaller holes, which means smaller gaps for the sample to get pushed into, so the sample will remain intact even if it's very soft and fragile. The clamp chamber is perfect for samples that would be deformed or damaged somehow if you tried to fit them in the smaller screw top chamber. This adapter plate has a piece of silicone rubber on it, which is a soft gasket that gets a better seal on samples with uneven top surfaces, and getting a seal in a capillary flow porometer is very important. If there were any leak around the test area of the sample, that could be picked up as a bubble point or as a confounding variable. Now we're going to look at how to set up an automated test in the Capwin software for a clamp chamber. To get started, you would hit the Auto Test button in the middle left-hand side of the screen, and that would open the Auto Test window. We should set the text fields to everything that describes the test that we're going to run. In this case, the test reference is WUCD, which stands for Wet Up Calculated Dry, which is how we would run most membrane tests. In this case, we're going to change it to DUWU, which would stand for Dry Up Wet Up, running a gas permeability test before we wet the sample and run the wet test. Whenever you have dry up or wet up, it means that you're increasing the pressure from 0 when you run that part of the test. If it said dry down or wet down, it would be starting with a higher pressure and reducing it down to 0. You want the sample ID to describe as best you can the sample with any punctuation or other markings that you want to describe it that wouldn't be able to go in the file name. By clicking Test Type, you can get back to this test selection screen. Here we have Dry Up, Wet Up selected, and then Through Plane. Through plane means the air goes from the bottom of the sample to the top of the sample, or the top of the sample to the bottom. In plane would be into the top of the sample and out through the sides. Sample diameter and thickness are very important for dry testing, or gas permeability, because it affects the permeability equation and calculations when we run those in the report program. After you've checked all the text fields, parameters, preferences, and settings, max pressure and min pressure, you're ready to start the test. Because we've selected a dry up wet up test, this test is going to start with a gas permeability curve, which is going to be a red line being drawn for a dry sample. When either the maximum flow or maximum pressure set by the user is reached, the machine will automatically end the test, ask the user to wet the sample, and then we'll start the wet test. To wet the sample, you can either remove the clamp or the hose, then pour wetting liquid onto the sample, click the OK button, and that will start the wet test. Depending on the test area, only a few drops of wetting liquid is usually necessary to wet the sample. Once you've clicked the OK button to start the wet test, now it'll begin the pre-bubble point test, which is showing you the F over PT curve, which we talked about in the membrane test before. The F over PT stands for flow divided by pressure times time, will remain constant and level until it reaches the bubble point and air starts flowing out of the sample. Now the test is going to start the wet curve, where it's going to start flowing gas through the sample that's still wetted with the wetting liquid. It's going to start with a very low flow rate because the sample is still saturated, as the bubble point only cleared out the largest pore. Then, as the flow increases, it'll begin to meet up with the dry curve, which is the gas permeability curve that had no wetting liquid in it. When the two curves meet, that's when you know the sample has reached permeability, and it's the end of the test because there's no pore sizes left to be detected. The program can be set to do any number of things at the end of the test. In this circumstance, we have a summary sheet pop up at the end of the test. Let's take a more detailed look at the reporting software. First, you'll start with the main Capwin screen, and you'll click the button called Open Report. Now the report program called CapRep will open with whatever previous settings were used last time it was run. On the right-hand side, we have various options and different report screens that it can open when you actually run the report. And on the left-hand side, you have your output options in the bottom, in the middle, pour table only, and at the top, the begin button, multi-plot, and settings. We're going to open a report, so you'd hit the begin button. A new window will open, allowing you to choose a data file. You can select any directory, folder, or location on the computer, or network drive. This is the summary sheet that usually pops up at the end of the test. It displays the results on the bottom by mean flow, pore sizes, and pressures. And then it has the flow on the left-hand y-axis, and on the x-axis is the pressure. Click the Continue button for it to move on to the rest of the report. Now it's opening the Capillary Flow Analysis summary sheet. If you scroll down on this, it'll display the mean flow pore sizes and other relevant information to the test. Hit the next button again and you arrive on the summary sheet. It has all the relevant information for smallest and largest pore sizes and some file information. Clicking the next button again gets us to a graph with flow rate by pressure. It's another way to display the graph that was shown during the test. This result displays an incomplete red and green line based on the dry curve, because it doesn't actually need the dry curve to give the pore size result for the test. Instead, it just needs the sample to reach permeability by the end of the test, and then it can calculate the dry curve from that. This plot shows pore size diameter in microns on the x-axis and cumulative filter flow percent on the y-axis. Cumulative filter flow is the percent of the total flow that went through the sample during the test, as detected per each pore size, which is represented by the pressures that it detected each flow rate at during the test. Clicking the next button again should get you to a histogram. This displays the percent pore size distribution by pore size. Each histogram bin represents the comparative numbers of pores detected in each area. Although the capillary flow does not detect the actual numbers of each pore size, it can give you a relative comparison based on how much flow went through each pore size. Clicking next again will get you to a line plot of the same histogram. This is a little bit more detailed view of what the histogram already displays, and again, it's based on how much flow went through each pore size, not by actually counts of how many pores are in each area. Back on the report program home screen, if you want to see a result that has a dry curve or a gas permeability, you would also click the checkboxes for the permeability text report and permeability graph, and then you would select the type of permeability result that you want. Then hit begin, and then select the file that you want that has the dry curve in it. If you select the permeability options and the file does not have a dry curve, it will just skip that part of the report. Just as before, this will open the summary sheet, and clicking continue will get you to the rest of the report program. Now back on the report program main screen, we're going to do a multi-plot. You can select the checkbox for graphing multiple samples, and then either hit begin or begin multi. Now you can select 2 or up to 12 different files by holding the shift key and clicking the files, or holding the control and clicking each individual one. Multiplot allows multiple results to be plotted on the same graphs. Each of the graphs will have 2 or as many results as were selected. Here you can see the blue line is a membrane result. This is a track etched membrane, and so all of its pores are in a very narrow range of pore sizes. Fabrics, felts, and papers will have a much wider range of pore sizes, with the cumulative filter flow flowing a little bit more evenly through each pore size. Having the line plots for each histogram plotted instead of the histograms on top of each other makes it a little bit easier to read. Here you can see the 2 different distributions for the samples, again with membranes being the blue lines having a much tighter distribution, as the pores are track etched, made to be in a small pore size range on the material. Back on the report program main screen, you can select the output device in the bottom left. This allows you to choose the type of file output. Before we were looking at screen outputs. You can also select tab delimited text, text documents, or Excels. When outputting to Excel, you can either select pore size reports or permeability reports, then save the data and output the other one if you want both. Click begin and select a single file, then the program will automatically output the Excel report with all the graphs and summary sheets that were selected in the original report program screen. Just like when you output the report in CapRep, there's going to be a summary sheet, graphs of the result with flow rate by pressure, cumulative filter flow by pore size, a histogram by pore size, and a line representation of the histogram.